Hi folks, Welly speaking here. Welcome to the second video of this first series. In this video, I'm going to provide a crash course on some of the Azure services as well as tools used in this video. The core idea of a crash course is to provide you with some fundamental idea of what each services are and the basic usage scenario. You will also find a link on each service so that you can learn more. However, for those of you who are already familiar with the logos shown above, feel free to skip this crash course. You can move on to the next video. The first service we will be discussing is Azure App Service, also known as Web App. It is a platform as a service compute that enables you to host web or API. One of the value propositions of app service is the fact that it is very easy to get started with very low learning curve. You can provision Azure App Service by choosing Windows or Linux worker. You can then decide if you want to bring your code and then run on one of the pre-built image or simply bring your Docker container by referencing it to your container registry. App Service comes with a lot of productivity features such as deployment slot, auto scale, and integration with Azure DevOps or GitHub. In addition to bring your own code, you may also choose the application from application templates, which you could find many of popular applications, blocks, and CMS. App Service support multiple programming languages such as .NET, Java, Python, PHP, and so many more. We will host our web API on Azure App Service on this demo. Let's move on to the next one, Azure SQL Database. It is a platform as service relational database running on the SQL Server engine. It comes with many pre-built features such as automatic performance improvement and recommendation, on-the-fly scaling, and built-in threat detection. Azure SQL Database can also work with an existing tool such as SQL Management Studio, which many of you are already familiarized with. It also comes with a great high available feature such as auto backup and point-in-time restore. You could also leverage active geo-replications and failover group for databases across different regions for disaster recovery purposes. In our demo, we will be using failover group to demonstrate the database failover. In addition to the SQL Server engine, Azure has other variations of the platform as a service open source database, namely Azure Database for MySQL, MariaDB, and PostgreSQL. The next service is Azure Traffic Manager. Traffic Manager is a global DNS traffic load balancer, which enables you to distribute your traffic globally. Not only it works with Azure services such as the cloud service and app service, it also works with any public IP address or public domain. So here's how it works. You firstly create a traffic manager profile by defining an endpoint name, which will eventually become your domain. You then register endpoints of your apps. This could be either in form of IP address or a public domain name to the traffic manager. Subsequently, you define the load balancing traffic routing method. So we have 6 or 7 methods today. Each of them can be used to solve different problems. We will be using priority in this demo to achieve the DR scenario. You also need to define other settings such as port, which we support HTTP, HTTPS, and TCP. Another important setting is probing interval, which determines how frequent do you want the traffic manager to check your application heartbeat. Finally, about tolerated number of failure, which determines how many times do you tolerate the failure to invoke the endpoint failover? One of the reasons why Azure Traffic Manager has much higher SLA is in fact that Traffic Manager is global or non-regional service. Unlike typical Azure service, you do not need to specify the region or data center location during the provisioning of the Traffic Manager profile. And this is because the Traffic Manager will in fact be deployed globally to multiple regions. Let's switch gear to the next service, Azure Event Hubs. Think about Event Hub as a highly scalable real-time data ingestion service, which allow you to stream millions of events per second. It is often used in big data pipelines. It supports popular protocols such as AMQP, HTTPS, or Apache Kafka. To use Event Hub, you first need to connect to Event Publisher. This could be any devices with supported protocols or other Azure services. You can then dispatch those events into different event consumers, which could be a customer service or Azure service such as Stream Analytics, which we will be discussing next. Typical messages or events sent from devices are in rather raw format. We need to further process or analyze them to make them into more meaningful information. This is where Stream Analytics can help us perform the analysis with SQL-like query in real time. We can then push the processed data to data sources such as Cosmos DB, SQL Database, or Power BI. We can also invoke Azure Function directly, just like we will be doing in our demo. Azure Function is a serverless compute platform which enables developers to write and run application or API in a very rapid way. It has integrated programming models, so-called triggers and binding, which simplify the way we program, especially interacting with other services. You can develop Azure Function locally with your private editor, such as Visual Studio Code or Visual Studio. Or you may also use web-based interface for light editing experience. Azure Function is fully open source project. You can find the runtime, sample code, SDK, etc. on GitHub. Not only you can run Azure Functions on Azure, you can actually also run it on your local machines or any other environment. Moving on to the next service, we will be discussing about Azure Logic App. While Azure Function is a serverless platform for executing your code, think about Logic App as a serverless platform for running your workflow. It allows you to design business process workflow with a UI designer from Visual Studio or directly on the Azure portal. You could build workflow for scenarios such as cloud to on-premise integration, business to business data exchanges, or business to social media workflow. It comes with more than 200 connectors that allows you to design your workflow efficiently, and we are constantly adding more and more connectors over the time. Here are some of the connectors that you could leverage to design your workflow. As can be seen on the screen, we have several connectors from Azure services, including Event Hubs, Event Grids, and Log Analytics. We can also see many connectors from the broader Microsoft service, such as Office 365 Outlook, Cognitive Service, and Teams. Not only supporting Microsoft services, we also have connectors which connects to the third-party services, such as Facebook, Twitter, Eventbrite, DocuSign, and so many more. If you can't find a connector which you need, you could either build your own connector or just simply leverage common connectors such as HTTP connector. In addition to Azure services, we will be also using two client tools during the demo. The first one is Postman, a very handy and popular tools that enable us to send and inspect HTTP requests. Postman can be installed on multiple platforms including Windows, Linux, or Mac. Another tools that we will be using is Apache JMeter, an open source software built on Java which eventually be used to perform load tests. It comes with very flexible and rich configurations options to construct the load testing preference. I will install it on an Azure VM. In our scenario, we are not using it for load testing, but rather periodically making requests to check the availability of our app. That's all for the second video. Thanks so much for watching, and I'll see you in the next one.